Hi everyone, welcome back to our channel. Today we are going to solve this problem on compensation theorem. The given problem is for the network shown below, a 5 ohm resistor. Okay, so this 5 ohm resistor is changed to 8 ohm resistor. Then determine the current in delta I. So he is asking find the current in delta I in the branch 3 plus J4 ohms using compensation theorem. So first, if you want to do it, we need to find out two values. One is compensating voltage, that is current into delta Z. Okay, and we want to find out the original current in this branch. Okay, how to find the original current is, so I want to find the current in this branch first. Okay, let's try to mark this current as I. Okay, I want to find out the current in this branch. Let's try to mark this as original current as I dash. Okay, so otherwise you can write down this as total current, this as the current I. So now let's try to find out I total. Okay, I total is nothing but the total current. By using current division, then I can find out I. Okay, so total current is equal to, you can see these two branches are connected in parallel. Okay, so whenever these two branches are connected in parallel, I'm going to get only one branch. Okay, so this is of 5 ohm and current is entering, current is dividing, then these two branches are connected in parallel. This is plus j5 into 3 plus j4 divided by plus j5 plus 3 plus j4, then you will be getting the total current. Okay, so the total current it. Okay, so with an applied voltage of 100 at an angle 0, so total current is equal to 100 at an angle 0 divided by 5 plus, when you convert this into an liquid form, this is 0.83 plus j 2.5. So 0.83 plus j 2.5. Then you are going to get this value as 15.757 at an angle minus 23.19 degrees. Okay, this is the total current, but which current I require? The total current I. So total current I can find out by using current division rule. Okay, so when you have a parallel branch, you want to find the current in this branch, I can find the current. Why? Because he has asked to find the current through 3.j4 ohm. First you have to find that current. So the current in this branch is total current. What is the total current? I total multiplied with, in this branch I want the current. What is the branch in parallel to this branch, which is nothing but j 5 ohms divided by the sum of branches which are connected in parallel, j5 plus 3 plus j4. So when you do it, substitute the value of 15.757 at an angle minus 23.19. You can write down this 5 at an angle 90 divided by j5, I mean j5 plus 3 plus j4. Okay, so this is j9. If you write down grouply, 3 plus j9. When you do it with your calculator, this you are going to get 9.48 at an angle of 79.51. So successfully we find the current I. Okay, so this is what the original current is nothing but. Now the compensating voltage is 9.48 at an angle 79.51 multiplied with delta z. So delta z means, how to find out delta z? Delta z old value is 5 ohm, new value is 8 ohm. Okay, so just take 8 ohm delta, that's why you're going to get minus 3 ohm. If you take determinant of this is nothing but how much? 3 ohm. Delta z is now how much? 3 ohm. Delta z. Okay, so now this is how much? 3 ohm. Just you can find out the value of VC. Okay, so therefore when you do it with your calculator, a small modification. This value, if you do it, you'll get a small value. So this you will getting as 8 point. So this is the value when you complete convert into an polar form, and you bring this value to the denominator, and the resultant value is 8.304 at an angle minus 4.75. Okay, then the resultant answer will be like this. Okay, 8.304 at an angle minus 4.75. Okay, so this is the value when you convert into complex and divide these values by this value, and automatically you'll get this is the resultant current I. Okay, so therefore when you do it, then the compensating voltage we are going to get it as 24.91 at an angle of minus 4.75 degrees. Okay, so this is the compensating voltage. Now what we need to do is, uh, you have to inject this compensating voltage in this branch. Okay, so now uh, we will apply this concept. So the same circuit we are going to redraw now. Voltage source is there, replace that voltage source with an short circuit, and already we are having an a 5 ohm resistor. This is Z, and you have to add the change in resistor, which is nothing but delta Z. That value is 3 ohm, and already we are having an the value of this one is J 5 ohm, and now this impedance we have to add, which is nothing but 3 plus J4, 3, and this is J4, and add the compensating in opposite direction. This is the value of compensating voltage, which is 24.91 at an angle of 4.75. Very simple. So first we have to find the current. I find the current using current division rule. First I find the total current, and I find the current in the branch here, which is nothing but the total current, and I find the current in the branch 3 plus J4. Why I find the current here is asked find the current in 3 plus J4. That's why I find the current in this branch, and then I'm applying the change. He is asking the change in current, which is nothing but delta I, the change in current in the branch 3 plus J4 when the impedance is changed from 5 ohms to 8 ohm. Okay, so that's why the change I had written here. Now we want to find out this. When you see this problem, um, the current is entering, and these two branches are now connected in parallel. Okay, whenever they are connected in parallel, you are going to get a single resistor. So that is nothing but, so this is what the equivalent we are going to get. So these two are connected in parallel, then we are going to get it as, this is 8 into J5 divided by 8 plus product of resistance divided by sum of resistance, and we are going to have, this is another branch. So this is the circuit what we are going to have. This is 3 plus J4 ohms, and now when you do the product and just, I'm going to get one compensating voltage, and you can see here these two elements are in series. Okay, so when you add it, we are going to get it again a single impedance. The value of this impedance is 3 plus J4 plus 8 into J5 divided by 8 plus J5. Just use your calculator. You'll be getting this value as a 5.24 plus 7.59 I you are going to get, and this is nothing but the compensating. And now we need to find out the change in current, which is nothing but delta I. So delta I is equal to the voltage is flowing like this, which is Vc minus 0 divided by R. What is the original value of R? 5.24 plus 7.59 I. Substitute the value of Vc here. Already we had done this value of Vc. Vc is 24.91 at an angle of minus 4.75 degrees divided by, when you convert this into polar form, this is 9.22 at an angle of 61.53. Therefore, the resultant current is 2.702 minus 109.03 degrees. So this is what the change of current using an compensation theorem. Okay. Hope you are able to understand. So initially what I have to do is we want to find the current in this branch. First find the original current. By these two are in, I'm repeating the problem, those are unable to understand. These two are connected in parallel. I'll get one resistor and this is one resistor and find the current. And I want the current in this branch. Why? Because in the exam with question itself has asked to find the current. So therefore, I'll find it by applying current division rule. Total current into opposite branch J5 divided by sum of these two branches which are connected in series. So I got the total current. Then I find the compensating voltage I into delta Z and I return this value. Okay. Now this compensating voltage I am injecting to this branch where the impedance is changing. So 3 plus J4 and in this branch I injected, and here the change of impedance is 5 and the change is 8 minus 5 is nothing but 3. I injected, total is 8. So again I can see here I want the current in this branch. Okay, so the current in this branch I'm going to find out. These two are in parallel. I written this formula. Again, after converting these two into a parallel, these two are again in series. So that's why I applied this addition of this value. I got this value. So therefore delta I is equal to plus Vc minus 0 by this value. I got this current. This is the procedure of solving the problem. If you feel the content is useful to you, please like the video. So just by watching video, nothing you'll get. Just you'll understand the procedure of solving. Just write down the given question and try to do of your own and verify whether you are getting the same answers or not. Hope you're able to understand the objective of this content. So like the video and share with your friends those who are studying the same subjects. Still, if you have any doubts how it is solved, let me know in the comment section. If you want to understand this, you can refer lecture video 50, the basics of this theorem. Okay, so those who have any doubts still, you can comment here. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. Thank you for watching the channel patiently. We'll meet in the next video. Yours obediently, Ram.